Hey, good morning. There's a few of us here, so as always, I appreciate when you can and you choose to get up and join me for the live stream. So thank you very much for that, and good morning. Um, oh, there we go. Good morning, Robo. Good morning, that one kid. Nice to see you guys. Thanks for being here. So yeah, we're just kind of moving right along with the routine, so that's hopefully a good thing from your end. So we're in week 13. We're going to start doing, this isn't a programming class, but we are going to look at how the Bash shell supports programming tasks, which in the context of the Bash shell, we call this scripting. Shell scripts, we call them scripts because what we do inside of one of these scripts is we line up a sequence or a series of commands. Some of the commands we line up are specific to the scripting environment. They're going to look like programming stuff. Some of the commands that we line up are command line utilities. So the cool thing about Bash scripting, shell scripting generally, is that you can take all of the command line tools that you know and you can sort of combine them to do larger tasks. And because you save them in a shell script, you effectively create a program that you can use and reuse, which is very, very handy for repetitive tasks or complicated tasks that you figure out how to perform once. And because you have a shell script, you don't have to figure out how to perform that complicated task ever again, because the shell script now contains all the commands that you used to solve that complicated problem. So it looks on the schedule like there are 2 weeks of shell scripting this week, next week, and I know next week has the Thanksgiving break in it, but we just keep going as if it's normal. Hopefully you have plenty of time to do what you would like to do around Thanksgiving week. But we'll have a normal week. I'll do the live stream as normal. You'll have a homework and a discussion as normal, which hopefully now you know what to expect and it won't interfere with your week's plans significantly. Worst comes to worst, you automatically have your lowest 2 homeworks and your lowest 2 discussions dropped. So if everything just kind of blows up and you don't find yourself with time to do work this week, you kind of have 2 free homeworks and 2 free discussions that you can just let go without any stress because they won't affect your grade. So totally up to you. These things, of course, will be covered on the final, so it's probably best if you do look when you're in the flow of things. But anyway, just so you are reminded that you have those options. So we have shell scripting this week, scripting next week, and then the week of the 28th, we're going to do a little bit more scripting because we're going to experiment with a tool that is slightly more complicated, and we will use shell scripts to save the sequences of commands that we use during this week of November 28th. So we'll still get to use a little bit of shell scripting and practice in that week. And then the distribution project is due on Sunday, December 4th. So if you haven't started, now is always the best time to start. That's going to come up pretty quick. So hopefully you've left yourself time to do the research, to do the installation, and to do some exploration from as a user in the distribution that you selected for that project. And then the week of December 5th is our last new content week. We'll run through a series of things so that you've been exposed to them. And then the week of December 12th, that's the last week of the semester, which is finals week. I'll do a review like I did for the midterm, and then you'll have all week to do the final exam and submit it, and then your semester's over. So we're getting pretty close. Okay, week 13, yes. So my plan today, actually, before I talk about the content, so my introduction to shell scripting is not, I don't think, going to be very, very long. I will take my time and try to explain things thoroughly like I always do, but I don't expect I'm going to run super, super long. So what I will do at the end of the week's content, I'll put a break screen in the video and give those of us who are here for the live stream a couple of minutes break. And then I will demo some of the desktop environments that were the subject of our discussions last week. So I tried a selection of them, and you'll see me install them. The KDE one is the big one. The other ones are not too big, so I should be able to do it during the live stream without there being massive interruptions. But I will try a selection of desktop environments, and hopefully as I'm doing that, you will have some sense of what they look like, what the differences are, what the difference between a window manager and a desktop environment is. Sometimes the differences, depending on the software, can be subtle appearing. Anyway, so you'll see me do that after we do the new content part. So I'll do the new content. I'll put a break screen in for a couple of minutes so we can get water, stretch our legs and stuff. And then I'll do demos of desktop environments. So that's completely bonus, optional material. So you can consume that if you want to or not want to, or how you want to, whatever you think is best for you. Okay, so that's the plan for today. Shell scripting content, small break, desktop environment demos. Okay, so we are starting shell scripting. I actually wrote one last week, a very simple shell script, so that I could use it to explore the concept of file permissions. So we will come back to that today, because shell scripts, when we create a file that contains our shell script commands in it, we have to make that file executable, or the shell won't allow us to execute the commands in that file. So we'll get a chance to review permissions a little bit, and we'll look at the basic building blocks of a shell script, and then try out a couple of experiments in a shell script. If you like programming a little bit, then I think you'll find shell scripts rather enjoyable, because you have all of the power of your command line utilities made available to you, which is not the same thing if you are writing code in a language like Python or C++, where you kind of have to roll your own often, and accessing command line utilities is not as straightforward as in the shell script. So it can be fun, is what I'm saying. All right, so we will create the shell script. We will have to make it executable. We will then execute it. We'll create variables and use them to make outputs of our variables. And then finally, we'll look and see how do we put comments in our shell scripts, which is just kind of the fundamentals of scripting or programming, either way. Okay, so a small amount of readings this week, which is probably welcome. Just the one chapter from the Bash Guide for Beginners, and then all the questions in the lab. I'll reference that, and also reference what I'm doing here in the live stream / video this morning. The lab assignment, as always, I'm going to open up the hands-on experiments. So what the hands-on experiments have in it is a couple of different things, and I'll do both of them. So we're actually going to alter our big P path today, and maybe I should actually add that to the oh no, I put it path. So we're going to alter our big P path on our system, and then we will create a folder for ourselves where we can store our scripts, and they will be then executable at the command line very conveniently. So we'll talk about all of that. How do you get something added to your path? How do you execute shell scripts that are on your path? It turns out it's very easy to do so. How do you execute shell scripts that aren't on your big P path? All of that stuff. So the hands-on experiment kind of reminds you about the setup of putting scripts on your big P path, which you don't have to do, but that's a convenience. If you put your own personal scripts that you created on your big P path, then you can type your script names, and the shell will go find them on your big P path, which is convenient. And then there's just a couple of scripts as examples. So there's one at the top here. It's called start.sh, which has a whole bunch of print statements, which in the shell environment are called echo statements. That's how you print stuff to the screen. And then they're actually printing out, reading in some information. I do want to add that. Read statements to the agenda. So we can print out information. We can actually have the user type in information at the keyboard and collect it inside of our script and use it. I can see that I used the -P, so I'll go ahead and add that to the agenda. Missed that earlier. Okay, so anyway, hands-on experiments just has a couple of scripts that you can try for yourself. One of them has a little text picture of a frog in it, which is a pain in the rear to type, but I'm going to go ahead and try to type it. Maybe, or something like it during the live stream today. We'll see. Okay, hands-on experiments. What are they here for? So that you don't have to come up with these ideas for yourself, but still have an opportunity to practice, to sort of examine a shell script, execute a shell script, all of those basics about how do you create and execute a shell script. Okay, that's the hands-on experiments. And then we have a discussion as always, and that's just to kind of enhance either by adding new things to learn or by sort of getting some extra learning around some of our basic content. So the discussion this week is about, okay, so we've learned what a shell script is and how do we create one, but why do people use shell scripts and what do they do? What do people in the real world do with shell scripts? So that's what the discussion is about, is for us to go out and kind of read about how are people in the real world actually using shell scripts on production Linux and Unix systems. So that we don't think that it's just sort of a pointless exercise, that we realize that people do use shell scripts to do productive work. And then, of course, as always, the reminder. So lab, as always, discussion as always. Please keep track of the due date of the distribution project, which is December 4th, which is very, very soon now. So I don't recommend that you wait till the last second, but if you're going to do that, at least make sure, please, that you leave yourself adequate time. It's the one sort of, besides the midterm and the final, it's the one big points carrying independent work that you do this semester. Okay, so there are all those things. Let me switch over to my virtual machine. And you're going to see that I have... Oh, wait. Yeah, I need to launch the thing, don't I? Yeah. Except for... Yeah, I'm going to do this separately. So I'm going to go ahead and do the scripting part. And then I'm going to shut this down at the break. And then I'm going to show you a configuration change that I want to make to support desktop environments. So let me get it booted up here. And then make it so that you can see it. Where is it? Oh, here it is. Well, where'd it go? That's not it. Well, now I can't get the stupid thing on the screen. Hey. Sorry, I got myself out of order. I'll just go add it. WMVM. There we go. Sorry about the delay. I had a little... All right. So sorry, that looks kind of messy. So let's go do some shell scripting stuff. So before I type anything, just a thing to note about, let me see where I'm at. Let me make a directory for this week. 13 CD week. 13. So I made a week 13 folder. I'm in it. a shell script is simply a file that contains commands that the shell can execute. That's all it is. We usually construct shell scripts to contain sequences of commands that do something useful. We don't have time in an introductory class to do a lot of shell scripting type of work. So what I want to do is just make sure that you understand what is a shell script, how do I make one, how do I make it executable, how do I execute it, and then we'll have a little bit of time to look at the various kind of programming features that Bash supports, and then create some small shell scripts to perform some tasks. So it's a file. That's all a shell script is. It's a file with commands in it. The commands include Bash scripting commands specifically, and also command line utility commands that we would use on the command line. But we use these scripts to collect sequences of commands to solve problems, perform work, those kinds of things. So just so you don't forget, if you're ever in doubt about doing something inside of a shell script, you don't have to be inside of a shell script to try the scripting features out. So we're going to do a whole bunch of, for example, echo statements. We're going to embed a bunch of these echo statements in a file, and then we're going to make that file executable, and then when we execute the file, it will execute all of the statements inside. But you can always come back to the command line and try out all of the things that we're going to do inside of our shell scripts. So echo statements is how we print things to the screen. We can also do read statements. And we can do this from the command line. So read name. So when I press enter there, what's happening is I've told the shell to read some keyboard input and store it as something called name, all capital letters. So I'm going to type Boyd. So when I press enter, it doesn't seem like anything happens, but when I echo $name, the shell returns to me that data that it stored from the read command. Now I'm showing you this from the command line just so you don't forget that a shell script is simply commands that you could also execute on the command line itself. But we tend to create scripts that are sequences of commands that, when put together, perform some larger or more complicated task. So those are two of the basics: an echo statement, a read statement, and then where it says read name, what that tells the shell to do is whatever they type in, store it in this variable called name. And then I can turn immediately around and use the $sign on name to have the shell print out whatever the data was that was stored with that label name, that variable, and Boyd comes back. Okay, so now let's make a script. Before we do that, I'm going to say which bash. So the reason why I do which bash is because I'm going to be doing bash scripting, and I want to embed in my script the fact that I want to use bash scripting features when my script is executed. So I'm going to note that which bash tells me that my bash executable is in /user/bin/bash. Got it. So let's do a hello script. So vim hello. I like to put .sh on my shell script files. You don't have to. Linux does not care about file extensions. So if you just say hello, it makes no difference to Linux. The reason why I put .sh is for my benefit. So when I do a file listing later and I see files with .sh on them, I know because of my own personal practice that those are going to be shell scripts. I just think it's a good idea to use file extensions, even though they're not required in Linux. These extensions can help you find specific kinds of files on your system. So here we are. So the first line is the shebang line. $! Exclamation point. We call this the shebang. We use the shebang to embed this piece of information in the script. So shebang, I'll highlight it. /user/bin/bash. So I know that my bash executable is in the folder /user/bin/bash. This shebang line guarantees that when this script is executed, it will be executed by the bash shell itself. Why does this matter? Well, if you are a user on a system that's already using bash shell, this doesn't matter. But if you have users on a system that are using some of the alternative shells, like the Bourne shell or the Corn shell or the Z shell or Fish, there are a lot of other shells besides bash. This shebang line guarantees that even if I execute this script from another shell, it will still be executed by the bash software itself, which means that all of my bash scripting commands will work as expected. So this is just something that you should do with a shell script. If you're writing it using the bash features, then shebang with bash, if that makes sense. Okay, so this is a bash script. I include that shebang line to make sure that it will be executed by bash. And let's just start with a basic thing. So again, hello there. Echo, what is your name? Read name. These are things that you've seen, and then we'll say echo, nice to meet you. $name gives us the value that was captured on the keyboard. So I have a print statement on line 3. Hello there, I'll print to the screen. A print statement on line 4. What is your name? And then a read statement. So the read statement on line 5 is going to cause the shell script to sit there and wait until the user types their name and presses enter. At which point the shell will print nice to meet you, comma, and then with the $sign in front of name, the shell will print out whatever they typed in on that line 5 statement. So let's try it out. Escape. So I'm going to colon WQ. Hopefully I didn't go too fast. I'll sit there for a moment. Okay, so I'm going to clear. I'm going to do a listing. So some things to note here. When it comes to executing one of your shell scripts, it has to be executable. And you may or may not remember, but if we do a long listing, we will see the permissions groupings, triplets. So I have read, write, not execute for user, read, not write, not execute for group, read, not write, not execute for other. Now it only really matters that me, the user owner, jboyd, can execute this file, but it is not executable. So when you are shell scripting, you have to make sure that the shell script is executable by at least yourself if you want to be able to execute the commands inside of that file. So the way we do that is we will use chmod. In my opinion, the easiest way to add a permission for one of those triplets is simply to pick the triplet, which in this case is the user triplet. I will add executability to it, and then I want to apply that to the script that I just made. So if I do a long listing now, I will see that now I, the user jboyd, have execute permission on this script. So that's important. If you don't have that, it will not execute. Okay, so besides being executable, what else has to be true? Well, the shell has to be able to find this script on your big P path. Let's try it. Okay, command not found. So what does that tell me? That tells me that this folder, week 13, is not on my big P path. That's okay, that's typical. But if the command or the script is not on my big P path, I can't just simply type in the name of the script and have the shell execute it, even though it's in this same folder. That's not how the shell works when it comes to executing things. The shell needs to know, find it on your big P path, or the shell needs to be given it as a little p path. So since it's not on my big P path, I can tell the shell, well, it's this thing. Please go execute this thing. So that is the absolute path, little p path, to this shell script. So it's not on my big P, it's executable. It's not on my big P path, so I give it a little p absolute path so that the shell knows where to find this thing so it can execute it. It's weird, it's just the way that it works. The shell will not execute a thing if it can't find it on your big P path, if it's not executable, if it can't find it on your big P path, or you haven't provided the little p path so that the shell can locate it. So there is the absolute path. I could have more quickly just said, actually, it's the hello in this folder that I'm currently in. So the dot is a shortcut for the present working directory. So I can save myself a lot of typing by telling the shell, you will find hello.sh in this folder. And then it finds it and it can execute it because it's executable. So that's a lot going on in a shell script. It's like a review of much of the semester. The big P path, the little p path, absolute and relative, and file permissions, all in one place. Also VI text editing, by the way. A lot of the semester just happened right here on this screen, which I think is kind of cool. Okay, so there's the script running. Let's go edit it. And let's make some improvements. So I'm going to show you two different things. So first thing I'm going to do is I'm going to, well, let's add a comment here. So this is not a shebang line. A shebang line is special because it starts with the pound sign and then is followed by an exclamation point. The pound sign, the number symbol by itself, simply means that this is a note that I'm placing in the script that is not to be executed by the shell. So this is different from a shebang. This is a comment. So one thing you can use comments for is simply to put notes to yourself, like this is my hello world script. It's my first bash script. That is a comment. It will not be executed by the shell because of that pound sign. Now that's not the same as the shebang line because that exclamation point changes the meaning for the shell, saying please make sure that bash executes this. The pound sign by itself simply means this is a comment. Now why did I say that there? Because you can use comments in two different ways. You can use a comment line to put a note to yourself, but you can also use a comment line to disable a line. So I'm going to disable line 6 here. And in fact, I'm going to put some space around it. So line 7 now is disabled. It will not execute. So I can use comments to disable parts of my script while I'm working on them, or because I don't need that part anymore, but I think I might want it for reference later. Whatever it is, I can use comments to disable parts of my script. Now the reason I did that is because I'm going to write this differently. I'm going to put in this line a -n. So I used the comment on line 7 so that you would be oriented to what I did that's different on line 8. And then if you do this for yourself, you will be able to kind of study the difference. So there's my change, and I'm going to stop there, and I'm going to save this and execute the script in a moment. I might have got going a little fast for people who are still not comfortable with VI editing. Okay, so line 8 is different from line 7. You'll notice the -n, and the challenge is to figure out what it does that is different. All right, so here we go. So here is the new version of the script. ./hello.sh. It's already executable. I don't have to re-executable it. If you're in doubt, though, just do a long listing. See, it's still executable. So I can edit it. It doesn't change its permissions. Okay, so that looks terrible. I'm going to go fix that. But you'll notice that I'm typing my name next to the question. What is your name? Boyd. Nice to meet you, Boyd. Let's go fix that, though. That looks terrible. I want a space right here after the question mark. All right, so clear ./hello.sh. So there's my name next to the question mark with that little space in there. Nice to meet you, Boyd. And then I'm just going to quickly show you again the difference. So if I disable that one and I re-enable this one so that you can see the difference. So what does that -n do? So the -n prevents the line break. So with the -n, remember, I typed my name next to the question. That's what the -n did, is allow me to type my answer next to the question. Without the -n, I type my name below the question. Both of them are fine. I just wanted to show you. Some people like the type your answer next to the question style. Some people like type your answer below the question style. It doesn't really matter. But these are kind of subtle things that you can experiment with to try to be comfortable with shell scripting. Okay, so let's look at another way of doing that. So I'm actually going to eliminate both of those lines, and I'm going to disable the old read name, and then I'm going to do -p is your name. So again, I've disabled line 10 and replaced it with line 11. So what line 11 does is allow you to put the question, the prompt, which is what the P stands for, with the read command. So read by prompting the name. Notice that I disabled line 7 and 8 because I don't need to echo the prompt anymore. The read is actually including the question or the prompt for me. So these are little things, again, that you can experiment with and kind of, if you're into this kind of stuff, you can just kind of figure out what your preferences and your style are. But we'll see what this looks like when I run it. All right, so there's my name next to. So the read -p style, put your name next to it. There's still not a space next to the question mark, so let's go fix that. Yeah, so I think it would look nicer personally. Oops. If I put a space after the question mark. So if I don't put a space here after the question mark, the shell won't print it. Fair enough, shell. All right, so notice when I type my answer with the read -p style, it's on the same line as the question. I personally like that style. And then the little space in there, I think, just makes it look a little bit nicer. Nice. What? No one even caught me on the nice comma to meet you, Boyd. That's weird. Let me go fix that. Okay, so there's echo and some read stuff. So you may or may not remember it. In fact, let's get out of here. You may or may not remember this command, this env command that prints all of the variables that your shell is automatically tracking already for you. It knows what your shell is. It knows what your home directory is. It knows what your username is. The shell is tracking all of this, and it knows what your path is, your big P path. Knows a lot of stuff already. It's tracking a lot of information, but you can use these things inside of your script. So we'll take like home shell and path. Why not? Home shell and path. Or home shell, I don't know, PWD. Let's say it that way. Home shell PWD. So we'll go down to the bottom and I'll say echo, here is some information about your environment. I'm going to put a blank line above that, which is simply by echoing empty para double quotes. So that's what that is. And then another blank line, and now I will print some of that information. So user, I feel like using arrows here. So if I do the $sign, if I don't do the $sign, then literally just the word user appears. If I use the $sign, then if there's information associated with that, which there is in my environment, it will print the value, which is jboyd-t. Echo home, echo shell, those are probably enough. So I'm just showing you here that you can take variables from your environment and you can use them inside of a shell script. In this case, I'm just printing them out because that's the only command that we've really looked at so far. But I'm simply printing out these variables that the shell is already tracking the values of for me. So $user gets me what the shell is tracking as that variable value. $home, that value. $shell, that value. Without the $, I should line these up. Without the $, it's just going to literally put the letters USERHOMESHELL with the $. If there's a value being tracked, it will give me that value. Okay, so let's get some information about our shell environment. Clear./hello void. And then see the two blank lines that I did with the echo empty double quotes? I should have put one at the bottom. That would have looked nice as well. So anyway, there you go. And where did jboyd-t come from? $user, because that is one of the variables in my environment that the shell already had a value for. Same thing for $home, which you can see in my environment. Same thing for $shell. Got a value because it's in my being tracked by the shell as part of my environment. Okay, I should put a blank line at the bottom. I think that would be nicer to do. YY on line 17, and then if I P on line, put on line 20, it will paste it on the line below. So I just did a copy and paste, YY, P, yank and paste. Okay, so there are shell variables. I've used the read to get a variable. I can also just make variables in here. So let's say the secret word is why turtle. I don't know. That's what came to mind. So I can put variables in here. And then I can, let's do a read. I like this variant myself. What is the secret word? And then I will echo, you think the secret word is $word to get its value. Yeah, let's put another blank line at the bottom. All right, so I just did lines 24 to 27. One, to show you that you can create custom variables for yourself. So line 24 is a custom variable. I just invented that inside of my shell script. Secret word, all caps, because that's kind of just a good style in the bash shell. And then the value is turtle. So I'm not using it yet, but the secret word is turtle. And then I ask the user, what do you think the secret word is on line 25? And then they type in a word. And then on line 26, I say, you think the secret word is this. So let's go make sure that part works. Void. What is the secret word? Elephant. So that one kid asked, I assume about the variable. So no, this variable secret word will be self-contained in this script. There are ways to export variables out into the shell environment, which would be not a typical way to go about it. So usually what you will find, in fact, almost all the time, inside of shell scripts, you will find the variables purposely self-contained. If you need a variable more widely available, then we would usually put that inside of a and like .bashrc file is where we would do that. But if you export a variable, for, like literally export space variable name in a script, then it is kind of pushed out into your larger environment when the script has executed. Okay, so you think the secret word is elephant. So last thing, which is the preview for things we'll do next week. So most of this week is simply about how do you put a script together, how do you make it executable, how do you execute it. But we will do a little preview with some of the actual kind of programming functionality of the bash shell. So let's go back into the shell. And here's our little preview. So if the quotes here are just in case someone types a space in their word. You usually want the quotes equals the secret word. Then that is right. Else the secret word was secret word. And then I'll go back and explain all this stuff. Okay, so I just added lines 29 to 36. So this is an if statement. If you've had CSCI 4, for example, or CSCI 20, or maybe in other classes you've done a little bit of scripting. So this is some of the programming functionality that's available to us in shell scripts in bash. We can do decision making. So in this case, the question we're asking is, does the word that they typed in match the secret word that I have in my script? That's that question we're asking on line 29. If the word they typed matches the secret word, then we will print the statement, you are right. Line 32, we say, otherwise, what should we do? Otherwise, we will say, sorry, the secret word was whatever it was. Okay, so the hard line here, the hard one, which is why I'm previewing it to get you to start noticing the important details. The spaces actually matter here. So if space, and then we open up for the decision component, square bracket, space, that's important. And then notice we put quotes around $word, and that's because if they happen to type an elephant or the cat, if we don't put quotes around word, that space would mess us up. So you'll see this always in shell scripting that we tend to put quotes around the variables when we're using them. So $word with quotes around it, and then a space, important, and then double equals, which is how we're comparing for equivalence, and then a space, and then $secret word also in quotes, just in case I change the secret word to have a space inside of it. So these quotes around the variables with the $ stuff, that's to make sure that nothing breaks should a space appear in the secret word. What if I made the secret word be green space turtle? These quotes will make sure that doesn't break anything. All right, and then another space has to be there. Close the square bracket, semicolon, and then we go down to the next line, then, and then we have what we're going to do if their word matches the secret word. Else, which is the way we say otherwise, what should we do? We print if they got the secret word wrong. And then notice how the whole section ends is with if backwards. So this FI means end of that section of if stuff. And then a blank line, and then print out a blank line. So I'll run it twice, and I'll get it wrong once, and then I'll get it right once, and we'll see how that goes. All right, the secret word, I will say cat. So I think the secret word is cat. Sorry, the secret word was turtle. Okay, let's see what happens if I get it right. Turtle. That is right. Okay, so that's a little preview. I'll go ahead and pop that up on the screen. There's something like it in the hands-on experiments, but I wanted you to see how I put the whole thing together. All right, so there is a script, and I think I talked about all the... Oh, well, I didn't, but let's go ahead and do that. So I'm going to make... I don't know what to call it, but let's go ahead and let's make another one so we can go through the process one more time. So I'm going to say vim. I'll just call it info.sh. So the shebang line, always first, to make sure that no matter what context this script is executed from, it will be bash that executes it. So there's a question in chat. It's a good question. So that one could ask, can you do data structures? Limited data structures. So the bash shell does have arrays as a data structure, but in terms of record types, I don't think it does, although modern bash scripting actually might have the record type. I'll look that up for next time and see. I don't think that modern bash has a struct. Yeah, as far as I know, it doesn't. So, I mean, I'm saying that in case I've like lost track and the modern bash does it. But as far as I've ever known, the only kind of way we can do structured data is with arrays in the bash shell. But we can kind of take advantage of things like cut and sort. And we do have kind of the means to simulate structured data. By reading files that have, you know, fields of data in them, like we've done with the cut utility. But I don't think there's anything like a struct, and I know there's nothing like a class in the shell script environment. It's a cool question, though. It'd be cool if they had it. Okay, so what was it? Oh, this is my info script. So I was just going to show you really quick. So that we can just do things like run the date command inside of a shell script. And then I can put a blank, and I can say something like shell scripts in this folder. And then some calsay action at the end just for fun. So the point here is just to show you really quickly that all of the utilities that you use, which is why that one kid's question was so interesting and useful, is because we have access, because we have access to all the command line utilities. We have all of those ways of accessing and manipulating information inside of a shell script: cutting, sorting, diffing, uniquing, lists, greps, all of the utilities. You can run them inside of your shell scripts just like you would from the command line, which means that you can do really cool stuff. This is not a particularly cool one. I just wanted you to see. I'm going to fire off the date command first, and then a blank line echo, and then just a message echo, shell scripts in this folder, blank line echo, and then an ls command showing only the files that have .sh at the end of them, empty line echo, and then a cal say with a little message, what else you want to know, kind of being snarky, and then a blank line echo, and that's the end of the script. So anything that you can do on the command line, you can do in a script, which is awesome. Okay, so just to show you, I have these two files. Remember that this newly created info.sh is not executable. It is a good default that Linux has, that when you create a new file, it is not by default executable, which is a security measure. You have to purposely make things executable that you want to be executable. And then I will /info.sh, this one. So there's the date. There is shell scripts in this folder, and then what else you want to know from the cow, and then a couple of blank lines sprinkled in. Okay, so there's a couple of examples of shell script. So what I'm going to do now, and it's perfectly fine if you have no interest in what follows. I'm going to put a break screen in. The big P path thing. I'll hang on to that idea. I think this was a better place to stop. The hands-on experiments this week give you one idea for putting your own scripts on your big P path. So you'll find that in the hands-on experiments. But I'll just hang on to that idea, and I will do that at some point in next week or the week after, once I get kind of a more useful script to play around with. Then I'll put that script on my big P path somehow. Okay, so I'm going to put a couple minutes of break in. That's all the content that is relevant to this week's lab. Everything after the break is bonus content. So if you want to watch me do it, you're more than welcome, and hopefully people will. But you don't need it for the final. You don't need it for the lab. This is simply if you are interested in kind of having me go through the process and kind of give you my reactions to these different desktop environments. That's what comes next. It's 8:53. I'm going to break and fire back up at 8:55 with some desktop demo stuff. I'm going to shut my system down because I need to change the configuration. So when I come back, you're going to see me first change the configuration on my virtual machine and then reboot it. So see you in 2 minutes. Oh, that's giant. It's doing all sorts of weird stuff to my face. Well, I don't need that there. Okay, so just thought it'd be helpful for people coming back to this later if they wanted to put a halt on it, to put the little break screen in there. So everything else is about desktop environments. It's all bonus material, but it's one of the fun things that you can do in Linux is kind of contend with all these choices of software. I am one of those people who think that at a point, too much choice just becomes unpleasant and overwhelming. So I'm pretty near that when it comes to window managers and desktop environments in Linux. It's probably one of the reasons why I kind of have the few that I am a heavy user of, and I don't try a whole lot of new things out. So I look forward to this every year when I do it because I get feedback from you guys about the kinds of things that you'd want to see, and that gives me an excuse to try stuff out. Before I do this, and it's going to take me a moment to show you the steps that I'm taking. So I need to do something to my virtual machine. You'll notice here, by the way, that I have a clone. So yesterday, in preparation for this, I went and read the discussion. I got kind of what appeared to be some of the more common requests for desktop environments. And then I cloned my system, and then I did all of these installs inside of the clone system to make sure I wasn't going to bust anything. Doesn't really matter. I could just reinstall it. But anyway, I have that clone, has all of this same stuff on it, and I know it works. So that's what I did. And now I'm going to do it to my actual kind of main Debian system, and hopefully nothing goes wrong. But if it does, I'll just rebuild it from scratch. It doesn't matter. So here's my made a clone. At least I recommend, if you have the hard drive space, that you clone it before you do this. So I'm going to go into settings, and yeah, you're not going to see a lot of this. So let me make sure that you can see it. How do I get this settings screen? What I want is the settings screen. And this thing's just going to fight me all the way, isn't it? It is. That's fine. Settings. There we go. Okay. So before I fire up this virtual machine, let me make it big so you can see it, and hopefully everything that I do you can. So we're going to go in here because I discovered in doing my experiments that if I didn't do this, some of the desktop environments don't work very good. So if you go to display, I'm going to enable 3D acceleration. Now, if you're one of the Mac users in UTM, I don't know how this looks to you. So this whole thing that I'm doing right now is really for the VirtualBox users. And I don't know how that might work for you in the UTM environment. Maybe someone can let me know if they needed to do something like this on a Mac. So for those of us using Oracle VirtualBox, enabling 3D acceleration definitely helped with my desktop environment experiments. So I'm making that change, clicking OK. And then this craziness again, but that's okay. Now I'm going to launch it and then do some installs. So I will fix this. Goodness. In just a moment. Oh, man. Okay, there's that. Let me get... Nope. I'm struggling to get these... No. Oy. This should be the last time I have to fight this crud. Add a source. Debian. Okay. Sorry about the little hiccups. I wanted you to see my configuration steps, though, so that you don't lose those. Okay, here we go. I'm going to log in as JBoyT because I have sudo privileges, so I don't need to be root. The first thing I recommend that you do is a sudo, let me clear, clear, and then do a sudo apt update. So we need to update the software database, see what the latest versions of things are. I have 6 packages that can be upgraded, so I'm going to go ahead and apply those and cross my fingers that they don't take very long to apply. So this is why on the agenda you see first apt update upgrade. So that's what I'm doing. It's not bad, so I'm going to go ahead and do it. I'm just quickly looking to see what is in there. There's some X server stuff. That's graphics related stuff. But anyway, that just worked out that way. Okay, so upgrade now. Let's go ahead. Let's go for it. So the package for Budgie. One thing you can do, by the way, you can apt search, and you don't need to sudo to do this. You can apt search Budgie, and there's a lot of stuff, and some of it kind of ran past on the screen. So you might do apt search Budgie, and then pipe it to less, and then stop at a screen at a time. The one that we are interested in is toward the bottom of the screen, Budgie Desktop. So that's the one that I'm going to apply. But I wanted to remind you about searching the software database by search word. Budgie is what we want. So we're going to do sudo apt install Budgie Desktop. And just a huge amount of stuff comes up. 239 megabytes, if you can see that toward the bottom of the screen, is not bad for a desktop environment. That is not bad at all. I'm just having a quick peek. Okay. I'm just curious to see what is being installed quickly. A bunch of libraries to support this stuff. Yeah, it's taking a little bit of patience. But fortunately, each new desktop environment before we get to KDE requires less software because the other desktop environments are bringing along with them a lot of the software that's needed for each other. So the Cinnamon install should be smaller than the Budgie one because Budgie has already installed a bunch of the stuff that Cinnamon will also need. Okay, all done. So I'm going to do 2 things. The first thing I'm going to do is I'm going to look and see where did Budgie install. Which Budgie desktop? Okay, which Budgie desktop? So there's nothing called Budgie, but there is a Budgie desktop in user bin. Let me see if there is one of these guys. There isn't. Okay. Not to worry about that just yet. That comes later. You'll see in my agenda it says one of these on line 40. One of these installs LightDM. It wasn't Budgie apparently. All right, so what do I do with this information? Well, I'm going to go to my, make sure I'm in my home directory. I'm going to go to my .exinit.rc where I have all of my window managers. I'm going to disable black box. Oops. And then I'm going to add exec/user/bin/budgie-desktop to my exinit.rc. I'll write it so you can see that at the bottom. So now when I do Start X, it should open up into Budgie Desktop so that I can see what that is all about. All right, so I've already written, so now I can quit. Now I will start X, and it should bring me up into Budgie Desktop, and this is it. This is all of it. Let's see if I right-click here. Yep. So the graphics are a little bit fancier. What kind of settings do I get? A lot. Now it's not fitting on my screen very nicely. Although if I do this, doesn't do anything. That's weird. So it didn't scale very well. Its minimum size is apparently bigger than my monitor, that in my virtual monitor. We have a little start button up here, which is the cute little foot. So how do I know this is a desktop environment? In part, it's because I have typically more controls. So I have, for example, I can do a VPN is already set up. I have sound controls. I have log out and restart shutdown controls. I have a calendar. If I go to the start menu, I have some built-in things. I get accessories, not much. Preferences, system tools, utilities. So it appears to me that Budgie is very, very minimal. It does have some setup tooling in it, like network configuration, which don't even have any to look at. What else did it have? Desktop settings. I now have the option for a screensaver. No, I don't want to do that. So it's pretty minimal. As long as I have a terminal, I'm happy. So there's Budgie. It is pretty darn minimal, and that's perfectly fine. So what happens if I log out from here? Okay, so kind of like the window managers, I'm brought back to the login session that I was in. When I did the start X command. So let's do Cinnamon. I did in my agenda put the package name, so I already kind of worked that out. So the package for Cinnamon is Cinnamon, so I will install Cinnamon. So 259 megs, 103 megs of archives. It looks like less, but that's probably because Budgie already installed a bunch of the stuff. I'm just having a peek. Okay, that seems all right. So yes, and hopefully that goes fast. So Budgie's all right. It's pretty minimal for a desktop environment. I would almost vote for a window manager over it myself for its minimalism. Why have the extra weight on your system when you don't really get that much extra functionality out of it? I saw Light DM go by. And I'll confirm that Light DM is on my path. So there's about to be a big payoff if you're sticking around this long, or for those, I mean, for people I won't be talking to, but who tried this, there's about to be a big payoff. So which Cinnamon, okay, now I saw Light DM go by. I'm sure that I saw Light DM go by. So I'm going to exit and see if anything happens. Okay, not yet. But I saw Light DM go by. Now, why is that important? It may not be, but let's try .xinit rc. No, I saw Light DM go by. Now, the reason I say that, and I'm going to add this. I'm going to recommend that we reboot after Cinnamon. So I'm going to sudo reboot. because I saw LightDM go by, and you will see what that means. So do you see I'm getting a graphical boot menu? That's new. Yes. So this is LightDM. The DM in LightDM, you see that on line 40 of my agenda, that stands for Display Manager. It looks like a login screen, but it's more. So a display manager is a graphical login screen, but it's also a display manager. If you click on this little tool up here, you will notice that it actually lets you manage which display environment you log into. And it even includes the window managers that were already present. So I'm going to pick Cinnamon so that when I log in, JBoyT, when I log in, it will take me straight to Cinnamon. So I didn't do anything with my Exinit RC because now I have this display manager that automatically installed itself when I installed Cinnamon. It may have been there from Budgie. Okay, so here is Cinnamon. It looks pretty good, I think. It is a very nice looking yeah, I'll just let that kind of hang over the top. So yeah, this is pretty nice looking. If I right click, that's pretty new. So this is a lot more, like this has a lot of what you'd expect of a desktop environment. A lot more than Budgie had to offer. Desktop background, does it give me any choices? It does. Oh. Is there an OK button down here? Do I just close and it happened? Oh, I did. Okay. So anyway, that's kind of desktop environment kind of stuff. I got these. I have a dock, basically, a file manager. That's a desktop environment kind of a thing. A graphical file manager. I have the a calendar, sound controls, network, printer, but I don't have a printer installed. Terminal. This one's pretty nice. Start button. Let's see what we get. We get a zip file manager program installed with it. So that's more like what a desktop environment you'd think would be. Would install with a bunch of add-on utilities with it. Did I not get any games? That's a bummer. Places, accessories, all. I like it. I think this Cinnamon is pretty nice, actually. They didn't get any games, but what are you going to do? Yeah. So there's Cinnamon. It's a good one. I think I could recommend it. It looks nice. It comes kind of with good defaults. All right, so there's Cinnamon. Let's get Mate, which I think is just Mate. So sudo apt install Mate. So starting to pile up the downloads. If you fill up your hard drive, there is a way to use apt to remove things. So you say apt space remove space the package you want to remove. So you could, for example, remove the entire Cinnamon or remove the entire Budgie desktop, and then you would free up some space on your system. So let's try Mate. I like Cinnamon. I think it's nice. Without having like too much, doodads going on. I thought it looked pretty good. There we go. This one is starting to try my patience, but it finally kind of sped up. So how do we log out of here? Let's see if we can find the log out controls. Oh yeah, there's a little get out of here guy. Log out. All right, so let's see if my display manager has mate as an option now. It does. All right, so let's see what mate looks like. Ooh, that came up quick. That I'm impressed with. So it's arranged differently. It has these different desktops. I'm sure I can change the desktop background. I like it when there's a few of these kinds of options. Let's try this guy. What? No, just this. Just this. Where's the OK button? I guess I just did it do. Oh, it did it. Okay. Okay, so it moves some of its controls back to the top. What's this little guy down here do? Restores hidden windows. Calendar. VPN. How do I get this calendar to go away? Sound control. I like this organization. So system. So you can see all these mate things that are like utilities that are installed with the desktop environment. Hardware managing utilities, and there's quite a number of them. So that is nice. This kind of gives you full graphical interface. Look and feel. There's probably, are there themes? Yeah, there's themes. Oh. All right, interesting. Search tool, applications. Added a document, a PDF viewer. That's new. There's no games. Anyway, so there's mate. You get the idea. Was the terminal easy to get to? It's one of the ways I judge these things. Is how easy is it to get to a terminal? I haven't seen it yet. System tools, mate terminal. Oh, it's kind of cool. It's got the theme in it. Pretty neat. Okay, X face. And then I'll probably shut down after this one. So this doesn't need nearly the same software as everybody else needed because everything's already in here. So this one's going to go fast. Now, I'm not going to do KDE because it's like 3 gigabytes of downloads. But you can see on the agenda, line 46 has the package name if you want to try KDE. Someone recommended Deepin, but there was a lot of like you had to create an account on a website, and I don't know, it just seemed kind of weird and very involved, so I didn't do that one. Someone also recommended GNOME, which is how you say it in that for GNOME desktop. But I thought once you've kind of seen all of these and you have a display manager, then you could go figure out what the package is for GNOME, and then you would know how to use the display manager to try it out. So this one I like that I go to system and the logout control is easy. Oh, that's kind of nifty too. Okay, so now I should have X-Face. This one's one of my favorites. I've just used it a lot over the years. Looks pretty standard. Minimize all windows and show the desktop. It comes with a terminal. I wonder what? Whatever. File manager, graphical. Is there a web browser? Yeah, I don't have a web browser installed. So once I were to install one like Firefox, that would work. Application finder. And then there's also this applications thing up here. So easy to get to the terminal. Still no games. And you can see also, by the way, the desktops are kind of picking up on each other's tools. Like here's the mate calculator. I'm going to try that. Let's see. There's the logout. Here's the calendar, notifications, sound controls, VPN, multiple desktops. So there you go. Anyway, that's there's a little tour of those four, and I'm not going to make you sit through 3 gigabytes of downloading KDE, but KDE if you do KDE, you'll notice like it's one of the bigger ones with a lot more stuff that installs with it. Probably it's going to have games, some developer tools. Um, uh, Back in the 90s, KDE was sort of Linux's answer to Windows 95. So it was a big deal for me because I didn't know my way around the command line very well at the time. So having KDE, which looked and felt a lot like Windows, was hugely helpful to me. My tastes have changed over time, where I have gotten to where I prefer a little bit less stuff. Those are all my backgrounds, though this one looks cute. I'll do that one. Yeah, that one looks all right. Okay, so there you have it. There is my desktop environment, sort of bonus demo. Thanks for watching if you watched this far. Have a great week. Next week is the week of Thanksgiving, but I will be here on Monday morning and do my normal thing, which is a little bit more shell scripting. We should be in and out within our scheduled hour because I won't have any demos to do for next week unless there's something requested. Other than that, have a great week. Thanks for doing all the great work that you continue to do. And I will see you hopefully on Monday next week. Take care.